in this class, and I'm not going to, after today, I'm not going to reply to these emails that I'm going to get the next couple of weeks. All right, the last day of class, I'm going over this with all my classes. The last day of class is Tuesday, April 21st. Okay? That means that y'all have one class on that last Tuesday is y'all's last class. I will continue to teach up to April 21st. Now I say that, I know you say, well, we know that, but the reason I'm saying it is because you are responsible for whatever I teach up to the 21st. Okay, so let me just say that I finish. Let's say that I finish chapter 4 and move on to, what is it, chapter 3? And I move to chapter 3 and start chapter 3. Let's say I start it and I go over 2 sections up to the last day of class. Then the last test will cover whatever I cover in chapter 3. Because I think I'm going to get through chapter 4 because I'm giving y'all kind of it's only 4 sections and I'm covering the second one today. So I think I'm going to make it through because antiderivatives build on derivatives. Derivatives, that's why we spent such a long time on derivatives, because if you don't understand derivatives, you might as well just hang it up. So I think I'm going to finish chapter 13 probably next week, or chapter 4 next week. I think. Okay? So anything I cover in chapter 3 will be on the last day of class, up to the last day of class. That's going to be your last test. And it'll be called Hubert's last test or Hubert's Unit 3 test. It'll be called something like that. Okay? And I'm going to get to that part right now. Okay? So let's just assume I'm going to finish chapter 4 and we're going to have a small quiz on chapter 3, which probably be less than 10 questions, depending on how far I get. When will that happen? Well, this is what I tell all my students. The last test, in your case, will be on Unit 3 material up until the 21st. Okay, whatever that is, will start, and the final exam. And if you've had me before, you know what this is. Both of those will start on April 22nd and last until the 28th. Okay? So on the last day of class, whatever I cover on up until the 21st on Unit 3, I don't care if I just cover 1 section or if I cover 5 sections. That last test on Unit 3 will start on the 21st or 22nd and go to the 28th. The final exam will also do that. Now, Miss Billy, you had me for 109. Did I do this then? I did this then, yes. Didn't I? I always do this. Yes. I always put the last test and the final exam, I give them the same amount of days so that way I can teach up until the last day of class. Okay? Now, let's talk about the final exam. The final exam will cover Unit 1, Unit 2, Unit 4, which we're doing now, and whatever I cover on Unit 3. Okay? So review those tests. Go to Gradebook. Go to Test. And go to the Review link. And you can review those tests. I make my exam, and Miss Billy can verify this as long as my other students. I make my exam from my test. Okay? You have 2 attempts. You have 2 hours. And usually, since this is a calculus class, you're probably talking about 25 problems or less. Okay? Yeah, 25 at most, which means 25 or less. Now, again, let's go over everything because I know there's going to be some, and if you don't watch the videos, then I'm sorry. The last test, which will cover Unit 3 material up to the 21st, and the final exam, they will start on the 22nd and go through the 28th. The final exam will cover Unit 1, Unit 2, Unit 4, Unit 3, whatever I cover, and you can review your test by hitting the review link in Gradebook. The exam comes from all my unit tests. You have 2 attempts. You have 2 hours to take it, and you're probably talking about 25 problems. After you have completed everything, after you have completed your unit test, all the homework you're going to complete, and the final exam, you go to Gradebook, and you hit overall grade. If you don't like the overall grade, then you go back to the final exam and the last test, and you retake it till you get the grade that you want. If you don't get the grade that you want, then I'm sorry. Okay? And that is the last week of class. So, again, the last day of class is Tuesday, April 21st. I will continue to teach up to April 21st. I do expect to finish Chapter 4 next week. Chapter 3, when I start it, I will go up until the last day of class, or Unit 3, which is Chapter 3. And that will cover the last test. It may be a test with 5 questions on it. It may be a test with 20 questions on it, depending on how far I get. And the last test on Unit 3 and the final exam will start on the 22nd and go through the 28th. And the rest, I'm not going to cover all that again, but I'm going to leave it up on the board because I don't want anybody from here on out. I mean, if you've got a legitimate question, you know what a legitimate question is. Calling me up and asking me when the final exam is going to be on, I'm not going to answer because I've just told you, the 22nd through the 28th. All right, so that being said, let's go over an indefinite integral just so everybody remembers what we went over the other day. And I've got to go to Walgreens and get me some black markers. I've used all my black markers, and I don't like that. So let's do the antiderivative. We're going to do 2. The antiderivative, or the integral, of 3x to the 4th minus 4x to the 3rd plus 2x squared minus 3x plus 2 dx. Now, I'm kind of doing a very long-ass one because I want to make sure y'all understand the basic power rule of antiderivatives. And go ahead, I'm going to give you 30 seconds to do that one, and then we'll do it together. The vodka goes down to the bottom. I have to shake it up. actually, alcohol is less dense than water, so it wouldn't go to the bottom. Miss Nino's like me. She's got all these windows. I had to set up in my breakfast room, and that's where all the windows are, so it's like bright city.
Yeah, and we don't have, the lake is right behind me because we live on the lake, and my mother-in-law doesn't have any, like, coverings over the windows, so I'm kind of screwed.
Well, I've got these blinds. I'm a bachelor, so I don't have very many curtains. So I've got these, pull down blind things, and if I was to open them up, oh my gosh, it would look like the Holy Trinity in here. It would be like glowing all over the place. So anyway, let's go ahead and do this. That's 3x to the 5th over 5 minus 4x to the 4th over 4 plus 2x to the 3rd over 3 minus 3x squared over 2 plus 2x plus c. Now after I do it, I go back and I see if I can cancel anything out. I only see 1. And cancel those 4s out. Oh, I need to make this big where y'all can see it. I'm sorry. There we go. Is that better? Hopefully y'all can see my screen. And that will give me 3/5 x to the 5th minus x to the 4th plus 2/3 x to the 3rd minus 3/2 x squared plus 2x plus c.
It's starting to lag again. Like you started writing whenever you were talking, like saying 2x. It started like showing you writing the problem.
Okay, well let me do this. Let me turn my phone off. I already turned my news off, thanks to y'all. Had to turn my news off so I can't hear it in the background. So if the corona creeps up on me, it's y'all's fault. All right, I turned that off, and next we'll have to turn the videos off if there's more lag. Okay, now I'm going to do another one, and this is just to check out if y'all were listening Tuesday. So let's do antiderivative of, I'm going to just do something, let's do 2x to the -3rd plus the square root of x minus 1 over x. How about the lag there? Was there still a lag?
You're still writing the problem, like that's what I'm seeing.
Okay, well I'm going to cut off my video, and y'all don't cut off y'all's videos yet. Let's see what cutting off my video will do. Since I'm sending out and you're receiving, let's see what happens now. Okay, so I'm going to let y'all do that one. Of course, you need to rewrite something before you start, and make sure I'm going to use my peach, my pink. My pink means that you need to rewrite, and my red means be very, very careful. Was that delay a little bit better? I guess you wasn't noticing because you were working.
Oh,
We'll try this one next. All right, so that's going to be, I'm going to rewrite, and as I'm rewriting, you tell me if there's delays better. So the antiderivative of 2x to the -3rd plus x to the 1/2 minus 1 over x dx.
You're still writing.
Okay, cut off y'all's videos and let me know if that makes it better. All right, so now I'm good, and I still want you to highlight this one red, because that you're not going to be able to take. If you were to take the derivative, the antiderivative of it, you would get something funky. You would get something like x to the 0 or something, or x to the, it wouldn't make sense. So don't, be careful on that one, because that's the natural log. All right, so here we go. 2x, I'm going to make that x to the -3 plus 1 over -3 plus 1, plus x to the 1/2 plus 1 over 1/2 plus 1, minus the natural log of x plus c. Now, you might want to, and I'm going to take a very yellow, I don't have a highlighter, so I'm going to use this yellow marker. Make sure you put those absolute value marks on there, because one, you can't take the natural log of a negative number, and two, you might have a smart aleck teacher, you will, and they will mark that wrong if you don't put absolute values on the absolute value of x. All right, so now we just need to do this, and that's going to be 2, and that's going to be x to the -2 over -2 plus x to the 3/2 over 3/2 minus natural log of x plus c. And now we take our handy dandy red pen, and I'm going to cancel the -2 with the +2, and I'm going to rewrite the 3/2 as 2/3. And now I'm going to write the answer, and y'all check out the lag. 1 over x squared plus 2/3 x to the 3/2 minus natural log of x plus c. Lag better?
You just finished writing.
Okay, good. So evidently the videos do influence the lag or produce it. So there's two problems that we went over Tuesday, and that is a indefinite. Why is it indefinite? Because you ain't got no numbers right here or right here. And the reason I stress that is because I went through Calculus 1 at Clemson, and I didn't know what a definite integral was from an indefinite. Teacher never went over it. So that's why I make a point to do indefinite, and then we're going to do definite today. Okay? So let's start with that. Go ahead and read it as soon as I can. I pulled this in. I love Foxtrot. I liked it when it was, I don't know if it's still out or not, but word problems, nothing but word problems. Thank you. Farmer Bob's vegetable garden is 20 feet wide by 30 feet long. Calculate its area in square footage. 20 by 30, let's do the f of x is equal to 20 and take the antiderivative from 0 to 30 of 20 dx. 20x is equal, or evaluated at 0 and 30 would be 20 times 30 minus 20 times 0, which is equal to 600 square feet. Okay, now, right here, he could have done this, and I've just found out that I can write on my, down here, I can write on this. I didn't know this. Look there, I got a pen, I got a highlighter. Y'all are in trouble now. So here is the old way of doing it. You know, area of a rectangle is equal to length times the height. Or you can actually use calculus to find the area under a curve or a straight line. Okay, now I play this, I do this comic strip no matter what calculus I'm teaching when I bring in the antiderivative or the definite integral. I do that because that's what you're doing. You're giving it a parameter. Let me give you an example. Distance equals rate times time. Okay? If you go 60 miles an hour, and you stay on the road for 3 hours, then the hours cancel, because this is really to show you this is equal to 60 miles per hour. And you travel 3 hours over 1. The hours cancel. And you're left with 180 miles. Okay, this is the same type problem that I just showed you with the comic strip. Or I could say on a graph, this is going to be miles per hour, and this is going to be hours. And I could make this 1, 2, 3, 4, 5, 6, so on. And I can make this 20, 40, 60, 80, and so on. I took my truck to get painted Monday, and I'm still waiting on it. It's about to drive me crazy. I don't know why I just said that, but I guess I was just thinking about it. They were supposed to call me Wednesday and tell me how it was going, and they didn't call me, and that pissed me off. All right, so we've got a 60-mile-an-hour line. You put that thing on cruise control, and you're going 60 miles an hour. And you stay on the road for how many hours? 3 hours. The area under this curve is 180 miles because the hour cancels with that hour, and you're left with 180 miles. Now, the reason I'm showing, and I'm going to show you a couple of these, is because a lot of people will say, the first thing they'll say is, well, hell, it's easier just to do the geometry and just say 60 times 3. All right, but how many things in real life are a straight line? Not many things, okay? So whether you're dealing with a horizontal curve in civil engineering or whether you're dealing with a business curve in marketing, a curve is a curve, and a curve is hard to find the area under unless you use something to find the area under the curve. And as we said Tuesday, the area under a curve is found with the antiderivative or the integral. And this gives us the definite integral. And I'm going to write this in red because you need to write it because it's important. The definite integral from A to B of f of x dx. That is called a definite integral. It has a lower bound and it has an upper bound. And usually when you're dealing with a definite integral, you're basically dealing with the area under a curve. So this is a definite integral. Here is your upper bound, and 0 is your lower bound. So 0 to 3, that's your upper, and 0 is your lower. So if I was to ask you, how many miles would you travel in an hour? You would say 60. We could play the video of the blonde talking about miles per hour. If y'all want to, we will. Y'all ever seen that video?
I don't think so.
Well, well, we'll pull it up so you can watch it. Let's go to YouTube. And a lot of people say, why are you pulling up this video? I'm pulling up this video because you just got to realize there are people that are this stupid. Okay? And she's very narcissistic. When you start to listen, I mean, when I first watched this video a while back, I was like, oh my God, I would hate to be married to this girl. She is so narcissistic. But anyway, I'm gonna pull it up right quick for you. And it's called The Blonde Explaining Miles Per Hour. And I'm waiting. There. Blonde explaining miles per hour. Per hour.
Unit.
There she is. Y'all ever seen this?
Alright, we're traveling from Logan to Boise, and I just proposed a math question to my beautiful wife, Chelsea. And the question, very difficult to calculate, is if you are traveling 80 miles per hour, how long does it take you to go 80 miles? Okay, what do you think, Chel? Let's go through the problem.
Okay, can y'all hear this okay? And is it lagging or what?
I can hear it, but the video is lagging a little bit. The
Okay.
sound
Yeah.
is.
Well, I'll show you the first part of it, and y'all can watch it. But here, I'm going to show you like the first few minutes of it.
Process, what do you think?
Well, if I run the mile in about 9 minutes.
Wait, what about the tire turning thing you were talking about? You think that affects it?
Well, I'm just guesstimating probably about, it turns about 400 times in a mile.
That's just calculate, like guessing calculations.
Yeah, I don't know how you would work that out.
It'll be tough.
Yeah, so, I don't know. Because if I run a mile in like 9 minutes, then, I mean, but that's when I'm out of shape. When I'm really in shape, at like 7 minutes is when I'm like really in shape. And then
Okay, I can't take any more. I'm sorry. I can't take any more. You'll have to watch it. Okay? Everything's about her, and it just drives me bananas. I'm sorry. So you'll have to watch it because all she talks about is herself in the whole thing, and I'm like, oh my God. That's why I'm not married. Anyway, let's go ahead and finish today. Let's go ahead and do the antiderivative, and I'm fixing to do this problem that we just did right here. This problem, I'm fixing to do it by integration. Okay? So I'm going to do the antiderivative. I'm going to try this purple here, this lavender. It says lavender. The top says lavender, but 0 to 3, v of t, which is velocity. And, uh-oh, we lost somebody. Who did we lose? We lost, I think we lost Miss Zanino. Let me pull her back up. Hold on a second. I don't want to lose anybody. I got to see how to spell her last name. Nino. There she is. Hopefully she'll come back in. Okay. So we've got 3. My lower bound is 0. My upper bound is 3. And my function, since it's a straight line, is 60 dt. So the derivative, there's Miss Zanino. Did you get kicked off or what?
Yeah, I have to go in about 10 minutes anyways.
Okay. All right. Well, make sure you watch that video. It's really sickening. So 60t evaluated at 0 and 3. So you take your antiderivative and then you set up the evaluation. Now write this down because you're going to see that evaluation bar. You need to highlight it. That's called an evaluation bar. I'm going to take my handy dandy yellow, and you need to highlight that because you're going to see this in calculus. Evaluated at 0 and 3. So that means that I'm going to plug in my 3, 60 times 3, minus, you're always going to minus, because that's what evaluate, you're subtracting. So I'm going to take my yellow highlighter again. No, that's green, that's not yellow. Sorry. You're going to minus 60 times 0. So whatever that number is, it's going to go there. Whatever this number is, it's going to go there. And you're always going to subtract. And that's going to give us 180 minus 0, which is equal to 180. This is a definite integral. This is how you do a definite integral. It's simple, but this is how you do it. Now, if you can go from here to here, from here to here using what we learned in 4.1, then you've got this covered. Because all this right here is basic what?
Algebra.
That's basic math, but algebra, yes. Okay? Basic math or algebra. You can say it was algebra because you're plugging and chugging. All right? So that is calculator work. This right here, again, out of the whole problem, 10% is calculus. So this is what we're going to be doing in 4.2. So let's do a nerd. And Miss Zanino, if you have to go, you go. Okay? I thought you got kicked off. That's why, since you told me you have to go, I'm not going to try to bring you in again. Okay.
Okay. I'll watch the video later on.
Okay. Have a good day.
All right.
All right. Now we're going to expand a little bit and talk about a curve. Of f of x dx. And this is what calculus is for. Okay? We show you the comic strip and the distance equals rate times time. We show you that to show you a transition. But this is what makes up calculus, because this is hard to find. Now, the calculus in motion, I wish I could show you that again, but I'm not going to try it because it's just a mess. So what you're doing is you could try to break this up into 2 rectangles, like that, and a rectangle like that, and then get an approximate. Or I could break it up into a rectangle like this, a rectangle like that, a rectangle like that, and these areas up in here are getting smaller and smaller, and I could break it up into a rectangle like that, a rectangle like that. The more rectangles I break it up into, what happens to the little triangles up here? They get what? Smaller and what? Smaller. The more rectangles I add, the more detailed my answer, my area is going to be. See there? So if I make my rectangle the width of a hair using the limit theory, and this is called Riemann Sum. We're not going to go over it because it's obsolete, but this basically comes from Riemann. If I spelled it right. Hell, I don't even know how to spell his name. All right. Riemann sum is what gives us modern day calculus, or Riemann, whoever pronounces it. And basically, if you take the area of a rectangle, let's say the area of length or base times height, and you count the rectangles, length of base times height, and you take the rectangles, and let's say there's 100 rectangles here. Then you multiply that by 100, and that will give you the area under the curve. Okay, that's Riemann. Riemann basically says that. And you take Riemann and you put the limit theory with it, and you say, make each one of these the width, make each one of those rectangles that you see right here the width of a hair. And if you make each one of these rectangles the width of a hair, then you have integration. Okay? So you take the limit theory, just like we did with the derivative, and you add it to Riemann sum, and you get the definite integral. All right? And it's again approximate, but this is going to be the most accurate, called a definite integral. I'm going to skip that one because I don't think y'all need it. Here's one. And we're still not doing curves yet. We're going to move into curves probably in your homework and Tuesday. So when you're doing your homework on 4.2 this weekend, you might see a curve or two, and I'll show you a curve before we leave today. F of x is equal to 1/2 x. That's that line right there. That purple line is f of x is equal to 1/2 x. So that means if I plug in 10 for x, I'll get 5. The area under the curve is that right there. That's what we want. Now, of course, that's not a curve. This is a straight line. But the concept in calculus and antiderivatives is the area under a curve. So a curve, a straight line is a curve in this section. All right. So I can just do, this base is 10, this height is 5. I could just do my geometry. Area of a triangle is equal to 1/2 base times the height, which is equal to 1/2 10 times 5, which is equal to 1/2 of 50 is 25. Now, that's good if you've got a straight line. But if you ain't got no straight line, it ain't going to help you. So, I'm going to set up my calculus, an antiderivative from 0 to 10 of 1/2 x dx. Now you can pull that 1/2 out and get x dx. Now I want you to take the antiderivative of x, and then I want you to multiply it by 1/2, and that's fine. And then I want you to evaluate it at 10 and 0. So go ahead and do that. I want you to do it. I'm not going to, we'll do it together. I'll give you all a minute. I'm looking to see if they replied to my, they hadn't replied yet. I was hoping they'd tell me I could get it. Maybe I should just go to posters. What do y'all think?
For sure.
I think you need the white.
What? What'd you say?
I said I think you need the whiteboard.
Yep.
Do you think it'll still be online in the fall?
What will be online? No, I don't think
classes?
so. I think, honestly, I talked to the president. We had an office hours with the president where we get to spend 10, 15 minutes talking to the president of the college, and he sees second summer session being back in classes.
That was the email because I had to sign up for Math 230 over the summer, and I can't go live in Pendleton or Clemson over the summer. I have to take it online.
Yeah.
And it's not offered at any of the colleges around me, so I had to sign up for one that I knew was going to for sure be online, which was like the Maymester.
Well,
I said
have, and I'm telling you this because I know who teaches the 230, and you're going to need it. So I'm going to show you on my YouTube. I have taught 230 before, so make sure you go to, well, my library. Where's my library? Where's my library? There we go. And I think you can find a 230 down here somewhere. It's been a while since I taught it because they moved the upper level calculuses to Pendleton. Just stop me if you see it. Summer, I think I taught it a year ago. There it is. Summer, write it down, 2017-30. I taught it in 2017-30. And also, if you look down further, I probably taught it several times before that. You'll just have to find it. I know I taught it more than once.
I will definitely use those.
And hit me up if you really need some help, because I know who teaches 230, and I'm gonna tell you you're gonna need it.
Yeah.
So make sure you.
Is the person like a back teacher, or they just kind of like there's not a whole lot like, I don't know, they just don't do very well, I guess. Because I had a math professor like that. Like he just read out the textbook last semester.
Yeah, and if you ask a question, they get mad at you. So,
Oh, okay, great.
yeah, 1/2 times, and I'm going to go ahead and take the derivative, so I'm going to take that out. 1/2 x squared over 2, evaluated at 0 and 10. Okay, you're gonna have to mute that the dogs. I can't handle that. I'm sorry. That's the only thing I can't handle is barking dogs. All right, so 1/2 times x squared over 2, evaluated at 0 and 10, and that's going to be 1/4. That's going to be x squared over 4, evaluated at 0 and 10, and 0 will cancel out, so you only got to do 10 over, that's 100 over 4, which is equal to 25. Okay, so we moved from doing 60 miles an hour or 80 miles an hour, whichever it was. Now we've put an x with it. So now, and we're trying to crawl before we can walk. We've done f of x. Where is it? I'm just trying to show y'all. Just hold on. We started you off with just a number right here. Oh, well, that's not the one I want. We started you off with here, just a number. And we got that. And now we moved you from a number to a variable with a coefficient. So what else is next? Well, let's do a curve. There's our x squared function. I'm just going to draw it. Okay, there's f of x is equal to x squared. And I want to find the area under the curve from 0 to 9. Now, there's no way in heck you're going to be able to do that. All right? Now, you could do this and say, well, that's a triangle. And 9, if I plugged in 0 for 9, I'd get 81. So I'm going to do the area of a triangle is equal to 1/2 of 81 times 9, which is going to be equal to 729. Somebody check my math. 729 over 2, which is equal to 163 square inches, square millimeters, whatever the case may be. So I just did geometry to find, but I don't want geometry. I want to take my limit theory. I want to take my hair, and I want to take each one of those hairs, and I want to take the limit theory, and I want to take each one of my hairs. There's probably millions and millions of rectangles at the widths of hairs. Okay? Millions. There's millions of them in there. And the length, the width of that hair is dx. And the height is the function. So the height is the function. And dx is the width of your hair. Okay, so, and the integration is adding all those suckers up, the millions and millions of hairs in here between 0 and 9. So, here we go. Antiderivative from 0 to 9, x squared dx. length times the width. That's basically what you're doing with the dx. That's why the dx has to be there. So that means x to the third over 3. Evaluated at 0 and 9. Well, I'll do 0 for y'all. I'm going to calculate in my head right quick. 0 divided by 3 is 0. So 0 goes out. So you've got 9 to the third. Y'all are amazed at my abilities, aren't you? And that's equal to, well, that 3 will take out, this is 3 to the third power, 3 to the second power. So that's basically 3 to the sixth power, right? Over 3. Take that out with one of those, that'd be 3 to the fifth power. So whatever 3 to the fifth power is, somebody do that for me. What's 3 to the fifth power?
243.
I'm sorry, what?
243.
So the area under this curve is 243 square whatevers. Inches, miles, acres, whatever the case may be. Now I'm going to show you something different. So let me know whenever you get the 243 written down.
I've got it.
All right, now let's take, y'all got it?
Yeah.
Oh, okay. Now let's take that same problem and let's add a twist to it. F of x is equal to x squared. Now I want to go from -4 to +4. I want to find this area. Now I'll give you a hint. There's 2 ways to do it. I'm going to let y'all try it and see if you can figure out the 2 ways to do it. So I'm going to give y'all a minute to work on it. Now, I'm going to take one side and I'm going to color it in, this looks like peach when I write it, but the pen says pink. So, peach or whatever. And then on this side, I'm going to highlight this side, verde. Now, I can do it like this. I can set up the left side as the antiderivative of x squared dx My lower bound is -4. My upper bound is 0. Plus the antiderivative from 0 to 4 of x squared dx. So that's going to give me x to the third over 3 evaluated at -4 and 0 plus x to the third over 3 evaluated at 0 and 4. Now we both know the zeros will what? The zeros will cancel. 0 cubed over 3 is 0. So you really, the 3's are not in the picture. So let's do the math. I'm not worried about the negative. Why? Because area cannot be what?
Negative.
Exactly. Write that down. Very important. Area cannot be negative. Then what does the negative mean? The negative means it's on the left side of the y-axis. That's what it means. Remember, negatives in science tell us what? Direction. That's what a negative tells us. If a negative, you have a negative area, that means it's either to the left of the y-axis or it's below the x-axis. That's what a negative. That's what a negative area will tell you. I don't know why. Got a sunshine ray coming through. Okay, there we go. So 4 to the third power is 64, right? So that this side comes out to be 64 over 3, and the negative means it's to the left of the y-axis. So of course, the right side is going to be 64 over 3. So what could I do besides adding 64 plus 64? What else could I do? I want somebody to see it and tell me. So somebody, what you see, tell me. I don't want to just add. I can add 64 and 64, and that'll give me 128. So my answer is 128 over 3. And I don't care about the decimal. You can do that on your own. Why? How else could I have done this problem? Anybody want to take a stab at it? Instead of adding 64 and 64, what could I have done? Okay, I'll do it. Let me get my yellow marker. Where is that yellow one? I had a yellow one a while ago that really wrote yellow, and now it disappeared. Damn Russians. Okay, I'll have to use this greenish yellow. I had a yellow one, and I don't know what happened to it. Somewhere on this table. This is what to this? What's the word I'm looking for? What is the peach side in relation to the green side? Starts with an S. Why?
Symmetrical.
Symmetrical. All right, look for symmetry. I don't know if I spelled that right, but symmetry. Always look for symmetry. If you have symmetry and these bases are the same, what's the distance from 0 to -4? 4. What's the distance between 0 to 4? If you have symmetry, you just multiply by what? Just multiply by 2. So I could have took 64 over 3 and multiplied by what? By 2. Now you need to write that down because there'll be sometimes when you're in your homework or you're in your doing a homework problem or whatever, and you go to the explanation and you'll see that 2 pop up. The reason you see that 2 pop up is because it's symmetrical. Hopefully y'all understand that. Everybody see it?
Mm-hmm.
Okay, one last problem before we move on to the next section, and that's going to be Tuesday, because I'm not going to spend a lot of time on that last section. Riemann, I think it's Riemann. I'm not going to teach you how to do the antiderivative and then go back 5 steps and show you how it was derived. I'm not going to do that, especially when time crunching. I don't think that's important. All right, so here we go. Same problem. F of x is equal to x squared. I want you to find the area from 9 to, I'm just going to think up a number, 36. No, let's don't do 36. That'd be too big. Let's just go 12. All right, so I want y'all to do that one. Give y'all a minute or two to get started. I'll set it up for you. 9, 12, x squared dx. Now this one don't have a 0, so you're going to have to do a little bit more math because the 0 isn't going to cancel out. You got a 9 down there instead of a 0. All right, what did y'all get for the antiderivative of x squared? Well, we've done it the last 2 times. That's x cubed over 3. Evaluate it at 9 and 12.
Hi there. It's
So that's going to be parentheses to the third over 3 minus parentheses to the third over 3. And now I'm going to plug in a 12 and a 9. Now what's 12 to the third power? That's 144 times 12. I have no idea. Somebody give me 12 to the third power. What do you get?
1728.
1728 over 3 minus 9 to the third is 81. 729. Somebody check my math over 3.
So I got, hold on, wait, maybe I did that wrong. Yeah, it's
729.
Yeah, I wrote it down wrong.
Somebody tell me 1728 minus 729. Dang old 999.
Yes.
999 divided by 3, which is equal to 333 square units. So there, when you have another number here, you want it to be 0, but if it's not 0, that adds another step to your math. And that is definite integrals. Now what we're going to do Tuesday when y'all come back from your homework, which I hope you send me some homework questions, we'll go over some more complex ones. I kind of figure what y'all will do now is you'll go do the homework and you'll send me some more complex ones, and that's what we'll do Tuesday to finish 4.2, because I showed you the simple ones, so hopefully y'all will fill in the gaps. And if y'all do all the homework and don't have any questions, that's even better. We'll go on to 4.3. And just for instance, right quick, and y'all can turn your videos back on. I'm going to turn mine back on. I'm going to, because I know Miss Cox needs to see something after you're going to ask. You're asking a math test question, right, Miss Cox?
Yeah.
Okay. Hold on just a second. That means, hold on. I'm going to show y'all something, but I can't remember. Okay. Main menu, syllabus and handouts. Just to give y'all a heads up on what I'm thinking about. I'm thinking about, yeah, see that? Okay, somewhere there's Riemann. Well, I thought I saw Riemann somewhere. Oh well. Area and definite integrals. Well, that's what we're doing right now. Properties of definite integrals. We might get into that a little bit. But somewhere up here I thought I saw Riemann. But I don't. I'm going to spend a lot of time probably in these two sections, 3.1 and 3.2. That's probably, I might touch on 3.6 because of explaining what those things are. But right now, we're shooting for, right now, you should be able to do some of 4.2 and maybe a little bit of 4.3 because those are the same things. And we'll finish 4.4 next week. So anyway, that's where that goes. And I'm going to hit the record button. And y'all have a great weekend and work on 4.1, 4.2, and 4.3, okay?